Welcome to ACADIA 2020, and thank you for joining us. My name is Maria Jablonina, and I'm one of the co-chairs of the 2020 ACADIA conference. I would like to begin by thanking our sponsors and the ACADIA community for making this event possible. Before we begin, I want to make sure that you're all aware of a few things. This session is currently being recorded and will be available to registered conference attendees for viewing after the event through November 30th. Conference attendees will be able to access the recording afterwards using the same link you used to join this webinar, accessible via our conference website. This session is also being streamed live on the live to the public on ACADIA's YouTube channel. This event is a Zoom webinar. Only the moderator and presenters are able to broadcast their video and audio. Webinar attendees are able to watch the session and contribute via chat and Q&A interfaces. Conference attendees are welcome to use the chat interface during the event, but we ask that all attendees remain respectful in your comments and observe ACADIA's code of conduct. If attendees have specific questions for the presenters, please use the Q&A function to ask your questions. Questions in the Q&A will be processed, selected, and asked by the moderator. Thank you for your cooperation, and we hope that you enjoy this session. When we began planning distributed proximities back in May, it was immediately clear to us that automation is one of the topics we care about and are interested in examining. Today, industrial robotics and hardware and software tools of automation have been at the center of the computational design and digital fabrication discourse for more than a decade. Initially developed for execution of repetitive tasks in the context of serialized production and manufacturing, robots and industrial machines have been since repurposed, reprogrammed, and rethought for an array of new tasks and new approaches to what they can do and what they can represent. However, the meaning, histories, and an array of metaphors surrounding robots inform design and creative practice even when not intended. This keynote event brings together designers, scholars, artists, and practitioners whose work engages with robotics and automation from a variety of perspectives. Specifically, in this session, we were excited to focus on the implications of automation tools in design and creative practice, as well as their complex cultural and political histories. I would like to now briefly introduce our speakers. Our first speaker today, Stefana Parasco, is an assistant professor at Princeton University, where her research focuses on computational design and robotic fabrication. Prior to joining Princeton University in 2019, she obtained her PhD from ETH Zurich Gramazio Collar Research. Throughout her work, she has been exploring computational design method and their potential role for architectural fabrication, ranging from agent-based design tools to multi-robotic assembly techniques. Her goal is to strengthen the connection between design, structure, and fabrication and the interdisciplinary nature of architecture throughout the development of accessible computational tools and robotic fabrication methods. Stefana's current projects include research on cooperative robotic assembly techniques for self-supporting structures, including spatial structures, bending active systems, and masonry construction. In addition, she is currently exploring methods of further integrating different fabrication systems into a design decision-making process. Our second speaker today, Erin Bradner, is a director of Autodesk's robotics lab in San Francisco. She and her research team are developing tools so industrial robots can intelligently make things by sensing, responding, and adapting to new information in real time. Under Erin's leadership, Autodesk's robotics lab is using artificial intelligence and closed-loop controls to teach robots new workflows in manufacturing and construction. Prior to leading the robotics lab, Erin also co-founded the generative design practice at Autodesk. Through research and leadership, she helped incubate the technology from concept to commercialization. Erin is driven to discover how to leverage intelligent software tools for smarter building, manufacturing, and design. Erin is a co-author on multiple patents in advanced design and publishes widely in academia. She holds a PhD in information and computer science. Our third speaker today, Sugwen Chung, is an artist and researcher whose work explores the dynamics between humans and systems. Her speculative critical practice spans performance, installation, and drawings, which have been featured in numerous exhibitions at museums and galleries around the world. Sugwen is a former research fellow at the MIT Media Lab and a pioneer in the field of human-machine collaboration. In 2019, Sugwen was selected as the Woman of the Year in Monaco for achievements in arts and sciences and was a featured speaker at TED in Mumbai, India. In 2018, she was an inaugural EAT Artist in Residence in partnership with New Museum and Bell's Labs and was awarded a commission for a project Omnia per Omnia, the project that you can also find in the curated project session on the ACADIA website. In 2016, Sugwen received Japan Media Arts Excellence Award for her project Drawing Operations. Our fourth speaker, Ellie Truitt, is an associate professor of the history of science at the University of Pennsylvania and the author of Medieval Robots, Mechanism, Magic, Nature, and Art. Ellie has also authored scholarly articles on medieval astronomy, pharmacobotany, the history of automata, early mechanical clocks, and pre-modern concepts of artificial intelligence. Her work has appeared in Aeon, the TLS, and History Today, and she has contributed to several programs on BBC Radio 4. She is currently at work on several projects about Roger Bacon, speculative technology, and temporality, about the co-creation of categories of modern science and medieval history in the 19th century, and about how medieval technologies produced narratives on Christian temporality and universality. Her research has received support from the National Science Foundation, the Andrew J. Mellon Foundation, the Huntington Library, and the Max Planck Institute for the History of Science. And finally, our session respondent, Georgina Voss, is an artist, writer, and educator. Originally trained in technology anthropology and industrial economics, her work explores the politics, presence, and deviance of large-scale machines and technical systems through performance, multimedia installation, writing, and investigative research projects. Georgina's work has been exhibited and performed in spaces including Tate Modern, Auto Italia Southeast, SD UK, London Design Festival, and TAC Eindhoven. Her writing has been published in places including The Atlantic, The Guardian, Science as Culture, Economic Science Fictions, Journal of Economic Geography, and Journal of Homosexuality. She's currently working on her second book that is focusing on experiencing systems. Georgina is Reader in Systems and Deviance in the Design School at London College of Communication, University Arts London, and also a co-founder and lead of Super Systems Studio. She is also founder and co-director of consultancy, Strange Telemetry, and currently a resident of Somerset House Studios. With that, please join me in welcoming our first speaker, Stefana Paraska.
Hello. I'll quickly get my screen up and running, but I want to welcome everyone and thank you, Maria, very much for the introduction. Okay, I can't speak and get this up and running at the same time. There we go. All right. So thanks again for the introduction, Maria. I'm really excited to be here, to be able to participate in this one-of-a-kind conference and keynote panel. I can't wait to see everybody else's presentations, but I'll get started with my own first. I'm Stefana Parasco. As Maria has mentioned, I am assistant professor at Princeton, and I have where I have founded the CREATE Laboratory Princeton. And CREATE stands for Computation and Robotics Enabling Architectural Technologies, which also summarizes my research motivation that is centered around the wish of enabling more technology use in architecture. What am I talking about today, though? It's honestly been a bit of a challenge to think about how to present my work within this new perspective that this year's ACADIA conference offers, mostly because I'm one of those people that really loves to get lost in the technical details, no matter how complex they get. And I do think it's really crucial to regularly zoom out from these details and look at what our work actually brings into the larger conversation, which is why I took the liberty to add an H to architecture and to shift the conversation towards the role of technology and deep technological understanding in architecture and design. As we know, digital technologies have strongly impacted many industries, making processes more material efficient, cost efficient, and safer. However, in architecture, we see quite some disparities in this digitalization process. Research is often focused on fabricating non-standard geometries, while on the other end of the spectrum, we see digital tools mostly used to automate existing and standard processes, which leads to the architect assuming one of two opposing roles, either becoming a specialist in a very narrow technical area or being an end user relying on pre-existing processes and tools. This leads to tensions even within our own discipline over the value of such technological development compared to, say, the value of creativity and critical thinking. And while the technical architectural field may often feel closer to engineering than the humanities, I think we are in a very unique position that allows us to reflect upon the implications of technical tools in design. But I am convinced that we can't do this without a very deep and thorough understanding of the underlying technical details. I think that only by engaging with technology to the fullest and embracing the challenges of entering completely foreign disciplines, are we able to advance these to benefit our own field and guide technological innovation towards what we really need instead of relying on other fields to develop the tools that we'd like to have. So I'd like to take you through about 2.5 projects of mine to showcase the types of developments that my students and I engage with from a technical perspective. The Brick Labyrinth was a teaching and research project developed together with students of the MASD Fab at ETH during my time as a research associate there. While the focus of the project lied on building a very large brick labyrinth consisting of over 10,000 bricks with robotic arms, the true challenge that came up was developing a structure that would work with purely dry stacked bricks, so no mortar or glue at all. In order to achieve that, we had to find ways to combine structural stability analysis with the constraints of robotic fabrication. We thus worked with students to develop a simple geometric stability analysis tool that we wrote from scratch, which was then validated and extended through physical tests. Instead of reverting to complex, computationally heavy and black box analysis tools. And this allowed us to understand how the structure behaves beyond the yes/no answer that one would get from a structure analysis program, which really enabled us to push the boundaries of what types of geometries can be constructed with dry stacked bricks, including these leaning walls held together solely by the friction between the bricks. At the same time, we also developed and implemented the robotic assembly process, from defining the robotic setup, designing end effector tools, sequencing logics, and path planning. We use multiple robots of different scales and sizes for different tasks. Directly developing these processes and custom control and simulation were crucial to a holistic approach of the design and fabrication problem. Ultimately, this enabled us to construct the 3-meter tall labyrinth in less than 3 weeks, which was afterwards fully reversed into a few pallets of bricks. In my PhD thesis, I developed cooperative robotic assembly processes for the construction of bespoke space frame-like structures. Focusing on the use of multiple robots beyond the single machine that are working cooperatively in order to open up the possibilities of robotic assembly beyond layer-based stacked structures. The construction process works by using the robots to alternate the placement of elements so that one robot always serves as a support to the already built structure. But the main challenge of this project was actually exposing and working with the interrelations of the very different constraints and parameters, and finding a design procedure that allowed me to explore the design space defined by the system to its fullest. So this required the development of a new node system, which influenced the structure's geometry, both locally and globally. It required me to find and test the material system and integrate it into the fabrication process, to understand the structural implications for the design through structural analysis and optimization, and ultimately to address the challenge of robotic movement planning in a setup with multiple machines and a constantly changing structure, which was really needed in order to find collision-free trajectories for these bars that had to be inserted into the existing structure. And just as a side note, it's clear that robots have a lot very many degrees of freedom and can reach many positions, but they are still constraints that they need to fulfill. They can't really reach any bar in any structure, so one needs to consider that when designing the structures. All of this led to a sequential design process that utilizes both structural optimization and fabrication information as design drivers, rather than in a conventional design process in a post-processing step, which showed that engaging with every single component to the deepest level of understanding was absolutely necessary to finding solutions to such strongly interconnected parameters. And this finally enabled the construction of many large-scale structures, such as this one, which consisted of over 300 elements, I believe, enabling me to fully explore the geometric freedom resulting from these processes. I want to touch upon one more project that we recently finished at my lab in Princeton, which is a light vault in collaboration with SOM Engineering and the Form Finding Lab at Princeton. However, I don't want to give away too much from this, since two of my PhD students will present it during the paper presentation session tomorrow. So I'll give you just a quick glimpse. I do want to point out how manifold the required knowledge for this project was. One could think that by working with specialists, in this case, many very highly skilled engineers, designers don't need to confront those challenges anymore, but can focus on the process of creation. But in order to achieve an integral functional design that is both stable and buildable with robots, we as designers had to be aware and find methods to engage with all the challenges of such a construction process, from defining robotic movements, defining a sequence, a pattern, identifying the design space that fulfills both structural stability and robotic feasibility. But more on this, as mentioned, tomorrow, I believe around 12:30 or so. Please tune in. To sum up, I believe that in order to truly impact our discipline, we need to dive forward into all the technical details of different fields, from structure analysis for understanding the behavior of structures during construction, through robotic kinematics and simulation for developing new robotic processes, to physical construction and testing to evaluate and advance our own systems. Only by engaging directly with the often really unfamiliar and sometimes scary details of technical disciplines can we be able to adjust to the ever faster advancements of other fields, such as robotics. And rather than handing designers ready-made one-click tools that do the work for us, I think that we should develop new types of tools that make the technical details understandable and graspable, and that allow architects to fully engage with these technologies, such as visualizing design spaces rather than visualizing a robot's movement, for example. Which is also what I apply in my classes, where I teach students the basics of robotics and programming to then find incredibly creative ideas transferred to reality. In this context, I think it's crucial to provide students with the technical knowledge and tools to understand how to design their own processes, rather than how to apply existing tools and processes. And with this, I will stop. Thank you very much.
Great, I think I'm up next. This is Erin. All right, I'm Erin Bradner. I'm the Director of Robotics at Autodesk, and Autodesk is a world leader in 3D design and engineering and entertainment software, and as you may know, we're best known for the software package AutoCAD. Our conference chairs curated this keynote to explore how robots and other industrial machines have been repurposed and rethought for new tasks across the increasingly convergent industries of manufacturing and construction. And in my 10 minutes today, I will help identify the signal through the noise of robots and automation. I'm here to talk about the current and future technology drivers underpinning the new ways robots are being appropriated. Working at a software company, I'm the first to admit I'm steeped in the ethos of advanced technology. I spend most of my time thinking about the trends in science and technology that are driving advances in the field. I'm not a futurist, still I believe that the future can and should be examined. But rather than stand in the dark and stare into the unknown, let's extrapolate what we know. Let's look at the technologies that are underpinning advances in robotics and see where they're headed. My team and I have identified 5 technology drivers impacting robotics today. I'll give you examples to illustrate 2 of these in a moment, but here's the complete set. In the near future, we believe robots will be inherently adaptive and will continuously adapt to unexpected conditions as they work. In other words, machine learning for robots will be commonplace, not just in academia, but in industry. In the future, robots will be steeped in information because they'll be rich with sensors. Today, there are roughly 2.5 million robots commissioned across the globe. The vast majority of these robots are deaf and blind. In the near future, sensor data for robots will be diverse and abundant. Machine learning and sensor input are 2 ways that robot programming will be automated. In the future, complex robot movement will also be automated by leveraging information that's already embedded in the digital and physical environments that robots inhabit. In my lab, for example, we're using 3D design information, CAD files, to automate robotic assembly. In the future, robots will be highly connected. Stefana is making progress in this space. In most industrial applications today, each robot is essentially an island unto itself. In the future, teams of robots will organize themselves around complex tasks. They'll work in parallel, they will divide their labor and share resources. Finally, we believe robot systems of the future will be easy to use. Robots, sensors, and other devices will be easy to network and to deploy. The science of kinematics and motion is arguably well understood, yet we're still integrating and orchestrating robots by hand. We're in the dark ages, so to speak. We think there's going to be a usability enlightenment in robotics in the future. Those are the technology drivers in robotics as my colleagues and I see it. If I were you in the audience today, I'd want some concrete examples of these technologies and actions. Now, there are many, many examples. Stefana gave you several, some of which others in the ACADIA community are pioneering as well. I'll focus on 2 technologies that my team are actively developing. First, a concrete example of how our research in machine learning is making robots inherently adaptive. In this research, we're using machine learning to assemble objects by training robots in simulated environments. Now, for me, our conference theme, distributed proximities, evokes the distribution of learning across the physical and digital worlds. Researchers across the world are using machine learning to train robots on motor tasks, such as picking objects out of bins. And there's a couple ways you could do this kind of training. You could set up a physical robot arm and record success or failure as your robot lifts, drops, and tries again to pick up objects. And if all goes well, your robot learns to correct its motion after hundreds of thousands of trials. Or you could train in a virtual world. You could use machine learning to train the robots to adaptively assemble objects in a simulated environment, then transfer that learning into the real world. This is a brick tower that the robots in our lab built after learning to recognize, grasp, read grass, and position bricks, all in simulation. And here's another example of adaptive robotics, this time at construction scale. Our recent research with ETH Zurich in machine-learned robot control is the first known application of reinforcement learning for robot assembly using architectural materials. Now, this video is moving slowly. It's not just your screen. We designed a machine learning system to connect timber joints. Here you can see these joints are tight fitting. The tolerance is 1 millimeter, meaning there's some finesse required to get these pieces into place. A human would adapt using a sense of touch to determine how much force to apply and at what angle to apply it. So we gave our physical robot a force feedback sensor, and we replicated that sensor in a digital simulation. And again, training happened in a simulated world. Here's a video showing the digital training on a 90-degree joint. The algorithm was way off at the start, but by iteration 107, it had learned how to fit the pieces together. What's remarkable here is that the robot adapted to new alignments in the real world without having encountered every alignment in the simulated world. Here, it's completing joints at 70 degrees, but it was only trained on 90-degree joints. And the real power of this approach is that it's generalizable to joints at different angles and at multiple joints. This video really amazes me because the system wasn't trained to complete 2 joints at once, but it generalized its learning so that it could fit 1 piece of wood into 2 joints simultaneously. These wood joints are just one example of the inherent adaptivity that's driving advanced robots. I should point out here that the machine learning systems that you saw take considerable expertise to set up. At the same time, explicitly programming robot motion is tedious and error prone. But what if you could distribute the work of programming robot motion between the creators and the robots themselves? Now, I'm not talking about fully autonomous sentient robots here. That's part of the mythology of robots that Maria mentioned. So sorry to disappoint the sci-fi fans listening today, but what we're researching is more procedural, how to manipulate objects and automate them. One of the technologies we're developing is cooperative force feedback to allow multiple humans and/or multiple robots to respond to each other in real time. Think of the last time you moved a heavy dresser with someone. Neither of you knew precisely where the center of balance was. You moved it successfully because you sensed how much to lift and to step based on how much it was shifting in your hands. You communicated with your partner through the dresser. In an experiment in our lab, we're doing something similar. In this simulation, you can see that the robots are using changes in location and mass of the object to derive their motion. 4 robots here know nothing about each other or about the mass of the table that they've been given to move. They're operating in a simulated world with physics, and they're lifting and shifting the table together using only a sense of touch to coordinate. Incidentally, this concept borrows from a classic theory in entomology called stigmergy, which describes the way social insects coordinate their actions by enacting changes in their environment. Now, since we're in lockdown in San Francisco, I can't show you that system in action, but I can show you automated programming of another sort. If you were at ACADIA last year, you might recall hearing USC's Scott Mitchell share a novel approach to automating robot programming at civil engineering scale. In this project, what you see here is the assembly of a footbridge, an 80-foot footbridge. Here, the robot goes to the physical locations that are prescribed by the digital CAD model of the bridge and precisely positions each steel tube for subsequent welding by a human. This is the completed physical bridge. It's not a rendering. I won't attempt to summarize the details of Scott's fabulous project in the time that I have, but I will offer that it's an excellent example of automation in both design and construction. The flawless positioning of its 550 unique elements are due in large part to its digital predecessor, the computationally derived 3D model, and to the humans and robots that collaborated together on assembly in both the digital and the physical worlds. Returning to the goal of this keynote conversation, we're exploring how robots and other industrial automation machines have been rethought for new tasks across the increasingly convergent industries of manufacturing and construction. So to close, I leave you with this video. I should say here that neither Autodesk nor I are affiliated with the company that produced it, Built Robotics. I'm sharing it because I believe it colorfully illustrates both the inherent adaptivity and the automated programming that I spoke of today. Yes, these robots are operating in what might be classified as a quasi-controlled environment, but they're also sensor-rich, mutually aware, and presumably connected. See, they stopped while that dog was crossing its path. My hope is that this video provides a commercially available counterpoint to the experimental work that I've shared in this keynote, and it's squarely targeted to the practitioners of today whose work is being reshaped by robotics and by automation. And it looks as if, thanks to his robots, this construction worker gets to go home early. Thanks very much, and I'll pass off my presentation.
Hello. All right, let's do this. Let me get this together now. It's really exciting for me to be here today. Hopefully you guys can hear me okay. Let's get this done. So thank you, Erin, for that great talk. I was actually artist in residence at Autodesk a little while ago, and it was just really interesting to see what is new in the robotics lab there. So hello, everyone. My name is Sue Gwen. I'm an artist and researcher currently based in Basel, Switzerland. It's really nice to join everyone virtually today. So I've been working with emerging technologies as an artist and engineer for the past decade at Media Lab and Autodesk and Google and some other places, and with an independent practice. I'm really interested in the role that this space has in shaping the cultural imagination about technology and how this wandering interdisciplinary curiosity can expand what we think of as art practice. And sometimes I describe it as a space of human and machine collaboration, where the mark made by hand meets the mark made by machine. And I've wondered, and I've speculated at maybe the future of human creativity not being in what it makes, but how it comes together to explore new ways of making, human and non-human alike. But allow me to indulge for a second. I think I would be remiss not to mention the current moment. I think at the moment, we're all trying to come to grips with the pandemic and how that adaptation, I'm interested in how it's necessitating shifts in how we come together as a community without altered norms of physical proximity. And it's really been inspiring to see that adaptation across different cultural sectors and how we've all been adapting in real time as a collective. And I'm really thankful to be part of that in some way. So with this really quick talk, I was planning on sharing a few things about the evolution of my project drawing operations, which is now in its 5th generation. I'd like to share a little bit about what I've learned about computers and collaboration and yeah, what all that has done in my practice. So it started with drawing operations unit generation 1, which used a simple computer vision algorithm to track the position of my pen in real time to create a mark on canvas through the mechanical unit. And I deliberately chose this rudimentary approach because it allowed me to see what was really beautiful and vital about the drawn gesture and the co-creative process alongside machines being not the perfection of its execution, but actually the beauty in imperfection. So in drawing operations unit generation 1 really changed the nature of what I thought of as my drawing practice at the time. And I think this is really sort of very much in line with the thinking around this conference. I've been thinking about for a really long time before this project of the etymological origins of the word computer, that is a computational system meant to produce automation. But for me, what I've learned through this project drawing operations, that it signaled a certain shift in thinking about machines beyond automation, but towards facilitating a new type of communication and a new type of way of knowing and sort of understanding and experiencing something like drawing and art practice that expanded the human sensory apparatus to include the non-human as collaborators. So I found it much closer to the Chinese translation of the word computer, which is electric brain, Din Lo. And through all this, it's been part of this journey of thinking about machines, not only as tools for automation or potential electric brains, but as abstractions of human intent that can catalyze new forms of knowing, thinking, and making. This is a little bit in response to and with some criticism of slogans like "make the AI do it" and these perspectives that are rather cheeky and simplistic, but generally terrible. I think phrases like making the AI do it describe what my colleague Seth Kamvar calls self-reinforcing technologies versus self-limiting technologies. This idea, I hope that through this ongoing process that technologies can kickstart a human process by creating technologies whose use doesn't lead to more use, but creating technologies that change the type of use that it's sort of participating in. So in this way, creating processes with robots that help catalyze new approaches, connections, modes of understanding, but aren't dependent on it, that don't atrophy physical processes in service of computational ones. And not to say that that can't be fun. I think an art historical precedent for this work is through Harold Cohen's Aaron project, who wrote his seminal painting program called Aaron in the 1960s. As you see here, Cohen stands back from the frame as the plotter executes his outputs as a painting artifact. And I think this is representative of perhaps how we culturally regarded technology then as something distinct from the human. But for me, that takes out part of the fun of working with machines, which is drawing with it and the drawing portion itself. As an artist, I'm interested in evolving my drawing practice to experience new ontological and epistemological processes and not let machines have all the fun. And to think about these interdependencies through this lens, to think about it as interdependence and not codependence. So I started calling this framework, a framework of human and machine collaboration, because as we know, the best collaborations are interdependent and not codependent, with all participants bringing something valuable to the table, or in my case, the canvas. So in Drawing Operations Generation 2, I was in search of, again, the beauty of a non-human move. And I wanted to create a drawing collaborator, a series of drawing operations based on drawing throughout the course of my life. So back then, I painstakingly collected as many of my own drawings as I could find, finished works and unfinished experiments, freeform sketches to tag for the AI system. And since I've been drawing for over 2 decades as an artist, it took a really long time, and it actually taught me a little bit about some of the labor that goes into training a neural net. This system not only draws upon what is drawn before, but helps catalyze new types of drawing behaviors in myself. It's helped me really engage with the differences between the machine readable to the machine interpretable. And it creates this evolving feedback loop, which I think is very much at the heart of the future of these collaborations. One where I can push my own drawing, coding, and engineering skills and evolve with this interdisciplinary process. And that's not in many perspectives, I think part of this expansion of my lens is knowledge projects, which is what has been going on. By translating something as story, and I don't want So for the 3rd generation of drawing operations, I became really interested in experimenting with crowd data through a multimodal robotic system linked to the flow of New York City extracted from public cameras. My intention with this project was to communicate a new form of landscape painting. At the time, I was thinking about techniques of vision, the ways in which single object detection differs from optical flow recognition, and how the machine views a crowd and how that unfolds in society. The computer vision engineer I worked with had a background in fingerprinting technology and talked about his desire to create a vision algorithm that privileged a person's privacy and viewed them as parts of movement in a scene. And the system that I developed was one that not only traced the optical flow extracted from those of crowd data, but it sort of ended up rendering what I thought of as like a moving impressionist painting. I really wanted to capture that within canvas, and this is part of an ongoing project as well. So These are just 3 quick generations of this multi-generational project. In the artifacts I've produced, I've often wondered where my line ends and the robot's line begins. When it's connected to the path data from public cameras, becomes even more interesting. And if there's anything that these advances in synthetic sensing technology has shown us, is that for me, it's been part of a certain Copernican trauma. And what I mean by that is that it's this recognition that the self is not at the center of the process and that we're all interconnected. And that becomes this really profound decentering of the human subject. I think particularly this year, the extent of our interdependency is a really major point of contention, but also transformation emotionally, socially, technologically, and microbially. And yeah, I guess that's sort of my rant about the collaborations I've done to date. I'm really excited to hear what the rest of the panelists have to say about it. Thank you.
All right. I think I'm up next, and here we go. So first, I'd like to thank the organizers of this keynote, Adam, Shelby, and Maria, for this invitation, and also my co-panelists for their incredible presentations so far. And I'd also like to note that I'm giving this talk from Philadelphia, which is the ancestral home of the Lenape people, and who have lived here as caretakers of the Delaware River watershed for thousands of years. So robots and intelligent machines appear in ancient literatures at least as early as the 8th century BCE, and they appear as built objects whose existence is largely known to us from written records, at least as early as the 3rd century before the Common Era. And so there's written evidence of many different kinds of automata, different sizes, et cetera, including really monumental ones used in courtly pageantry. For example, there was a moving, lactating statue of Isis that was part of Cleopatra's triumphant entry into Alexandria in 47 BCE. So today I'm going to concentrate on examples like the statue of Isis that are intended to convey the presence of the ruler and to amplify that authority. And in considering agency, I'm going to examine the links between automation and enslavement over about 900 years, from about 950 to the middle of the 19th century. Both artificial servants and enslaved persons appear as liminal objects that glorify the individual at the center of the court and comment on a spectrum of humanity, and they embody the use of technology to articulate power over nature. So the first group of objects that I'm talking about are ones that are no longer extant and were not represented visually. So we only know about them from textual sources. So just to give you a heads up that these are some text-heavy slides coming your way. So both the Hellenistic culture of the Ptolemaic dynasty in Egypt, which Cleopatra was the last ruler of that dynasty, and then the Abbasid Caliphate in Baghdad influenced the later Greek-speaking Byzantine Empire that was centered in Constantinople. In the middle of the 10th century, the emperor incorporated monumental automata into courtly pageantry in a fusion of these two influences. The throne of Solomon, as it was called, in the imperial palace in Constantinople was where the emperor received foreign emissaries and other high-ranking foreign guests. And this marvel, which is attested to in Greek and Latin sources, included a levitating throne with the emperor sitting on it, surrounded by mechanical lions that roared and lashed their tails and stood up and sat down, and then a gilded tree on the branches of which were artificial birds that flapped their wings and sang. These automata moved and made noises at different times during this highly scripted ritual, while the emperor remained silent at a remove. So in this Byzantine court ritual, the automata spoke for the emperor at key moments of the ceremony alongside the emperor's human servants. And both the human and the mechanical servants convey the enormous power of the emperor and wealth, and are intended to impress and even terrify viewers. So objects like these were known of in the Latin Christian West only as foreign objects. They were unable to be created by indigenous artisans until the turn of the 14th century. Yet even then, the earliest example of automata in the Latin Christian West, located at the Palace of Hesdin, shares with the throne of Solomon the purpose of using automation to convey the presence and power of the ruler. So the Count of Artois, Robert II, had spent much of his adult life in southern Italy and in Sicily, and he encountered automata there in Islamicate or Islamicate-influenced courtly settings. And so when he returned around 1290, he oversaw the installation of multiple automata in his estate, including mechanical monkeys that were covered in badger skin, and an entire room with a massive aviary in it, in which real and artificial birds mingled together. And so the purpose of these mechanical marvels was to discomfit and amaze the guests, and they were installed alongside other animal species that he introduced into his estate. And so they were intended to just be symbols of this power over nature that he had. And the mechanical monkeys were intended to be taken, at least at initial first glance, as yet another exotic species that the Count had brought to his lands. So by the first decades of the 15th century, about 100 years later, the estate had fallen into disrepair, and it had also come under the control of the Duke of Burgundy, Philip the Good. And Philip insisted on massive renovations of the estate. If under Robert's originating visions, they were there to provoke awe and wonder and double takes, under Philip's revision, the automata were raucous and disruptive. And we know this from a bill from 1433 that lays out in detail the nature of the work that's done. It includes figures that squirt water on people, numerous trick mirrors, booby traps that cover unsuspecting courtiers in soot or flour or feathers, a wooden servant, a figure in the middle of the gallery that actually speaks on behalf of the Duke and tells everybody they have to leave. And then the people who obey the rules of etiquette and do leave are then beaten by other figures and pushed into the water. And the people who say they don't want to leave are going to be wet and pushed into water in different ways. And throughout all of this, at the Duke's specifications were installed hidden jets of water to, quote, wet the ladies from below. And so in this instance, the discomfiting obstacle course is laid out as a result of the Duke's wishes. The automata speak on behalf of him, just like at the throne of Solomon, and they move guests through the physical space in the sequence that the Duke wanted. So as artisans became more familiar with the complex technology of automata and more skilled in deploying it, automata became part of courtly pageantry at princely courts throughout Europe in the 17th century in smaller and usually less disruptive ways. So the purpose of these still intricate and amazing objects was to communicate the artistic and technological expertise of the prince or the people who worked for him, and his control over natural forces. And in the same period, which coincides with the emergence of the brutal regime of enslavement of African and indigenous people in the Atlantic world, we note the emergence also of the enslaved black page or groom in early modern European arts and letters. His appearance, which often includes some orientalizing aspects, like a turban in this case, likewise represents power over nature, in this case, the power to civilize or Christianize. In courts across Europe, enslaved Black people were taken to convey princely power and took on ornamental roles. In this image, you can see the figure of the enslaved groom behind the woman who's the central figure. He's dressed in silk and is wearing a collar, and he's holding a dog, which is another symbol of a faithful companion. And he's contrasted with the parrot that symbolizes the exotic bounty from where he comes. But the point is that he is compared to two animals in this image rather than to the woman who is at the centerpiece. And often automata and enslaved Black people were displayed together as part of the same pageantry. or in the same entertainments as at Versailles during the court of Louis XIV. And both intricate automata and enslaved Africans share a number of conceptual linkages. So they both represent authority over nature. Africa in this period was depicted often as a wild place that was full of natural bounty but lacked industry. So therefore, the enslaved African, clothed in European attire and given a visible ceremonial position within court, conveys the ability to civilize untamed nature. Mechanical marvels communicate the power to surpass nature with technology. And furthermore, both enslaved people and automata are connected through the conceptual link of the servant. In the medieval period, we see across linguistic, ethnic, political, religious contexts, automata being imagined as ideal servants that far surpass their human or animal counterparts. And both are also seen as liminal figures that are not human, but pretend to full humanity. They point to the existence of a continuum of humanity. For example, enslaved Black people were widely viewed as figures between rational white agents and soulless machines. And the presence of both automata and enslaved people to do the same conceptual work allows us to view the assumptions and meanings behind assertions of humanness. The conceptual links between automata and enslaved persons persisted into the 19th century. Both the court and state power were, and are, deeply invested in claims of humanness and mobilized the same symbols and existing associations. As scholars have shown, slavery made European industrialization possible by producing a surplus of capital that fueled economic expansion, but also by establishing the plantation rather than the court as the primary site that configured the relationship between enslaved people and machines. And reflecting this, minstrel automata proliferated in the antebellum period. And even outside the plantation in the United States, the same logics that linked Black people and automata together obtained, including finding expression in popular culture. Showman and huckster P.T. Barnum got his start in 1835 by exhibiting Joyce Heth, an elderly African woman who had supposedly been George Washington's enslaved nursemaid, alongside the Turk, a mechanical chess-playing figure that actually worked by means of hidden human agency. And at one point, Barnum actually arranged to have a plant come in and claim that Heth was an automaton rather than a person. And the point here is that either way, her humanity was questioned and denied, even as she was used literally alongside a machine to build Barnum's reputation. So just to conclude, I would just say that taking a longer historical view and a wider lens in considering the nature of automation and its links to agency reveals productive moments of affinity and discontinuity. For example, in the context of Atlantic world slavery, the reproductive labor done by enslaved women was fundamentally important to perpetuating the institution of slavery. At the same time, the period between the 17th and 19th centuries is marked by the appearance of stories about learned men, like René Descartes, making automaton children. So questions of reproduction, labor, and definitions of humanity cohere around both enslaved people and automata, even if expressed differently. Deeper engagement with historical material makes clear the longstanding linkages between robots and enslaved or subjugated people, and how both are used to prop up specific ideas about who is fully human or a more fully realized individual. Put another way, whose humanity do automata and enslaved people serve? But at the same time, older histories of automation and robots make it possible to reimagine ideas of what these objects should look like or could look like, how they might interact with us, and how they might be used to liberate the disempowered rather than embody subjection in new ways. And so greater understanding of these histories can offer new perspectives and possibilities for imagining and making robots and AI now and in the future. Thank you.
So thank you so much, guys. And I think it's my job now to bring this together and steer us into an active discussion. So before I get going, thank you so much, firstly, to the organisers for this brilliant event. When we were approached about it a couple of months ago, it was one of those things which was genuinely a joy to think about and wonder what we were going to hear and see and how I was going to engage with it. And thank you also to the panelists. We'll be coming on to a little bit of grilling about what you're thinking and what you're doing. But to wrap things up, I'm going to bring together about, I guess, 5 minutes, I don't want to take too long, of thoughts and synthesis about what we've just heard to try to bring it together in one place. As I think we've had a comment here, there is the Q&A box. If you audience members want to throw in some questions there, and we'll pick those up after this discussion between us too. So a little about me very briefly. As Maria said, I'm a reader in systems and deviance at London College of Communication, University of the Arts, London. My background is in the, I guess, social sciences around economics and anthropology before I moved into art and design. So a lot of the themes we've been thinking about today of where the kind of technicality and the sociality and the cultural part of technical systems sit together is exactly the thing that I'm super interested in. And we are, as some of the panelists have said, we are at this very specific moment. You know, at any time a panel on the ideas around automation, agency, robotics and robotics would always have a particular kind of heft and weight in the public imaginaries. But it also feels, particularly in this past year, that conversation has grown, both from the kind of technical advances that we've seen, some of the panelists have talked about, and over the past decade, but also this particular moment we find ourselves in, where we've been thinking about what futures are coming, what's on the horizon, what's our role in building them, what they look like, how they behave, who constructs them, who uses these systems. And I think particularly for, again, these kind of robotics, automation, these are words that have kind of like a buzz to them. They have kind of like really solid expectations of what they might bring into being. So in the fields I work with, there's this idea of socio-technical imaginaries, these kind of imaginations, images of a social life that might center around the development of certain technologies. And it's particularly potent for automation. There's very clear kind of senses in these imaginaries of how these things behave and what they do. But by realizing that they are imaginaries, they allow us to tease things apart, to ask what is expected, you know, what should we have on the horizon, what should be coming into us? And I felt what was really lovely, and I was, you know, genuinely delighted about with these talks from such brilliant people, was that across history and time and different forms of practice and engagement, that was exactly what we saw. This kind of this teasing apart and tugging of saying, like, you know, you've got these ideas of how this stuff is going to work, but actually it's much more complex and rich and interesting than that. So to start where we just finished, Ellie's wonderful talk on this like very, very long history of automation, which I adored. And I can just imagine being one of your students or kind of sitting in a conference coming to this brand new and thinking that when we think about automata or robots, like they're a certain shape, they're a certain size, they're a certain thing. And actually you're saying, you know, go centuries back, they behave in certain ways, they exist in certain forms. They're very different to what you might expect, but they still inhabit and carry with them a lot of the power dynamics that we see working through technical systems today. And I was thinking of students as well, with Stefana talking about the types of teaching that she does, where her students might be imagining they are about to build a robot in a certain form, using certain kind of off-the-shelf tools. And in fact, you're saying, well, we need to kind of overhaul that and rethink not only the tools that we're using to give us something that allows us to have, you know, more control, more agency, more knowledge of what we're doing, but also to kind of spread out from this discipline for her, you know, for architecture, to see this as a more holistic picture, that there's something richer in kind of understanding where these connections lie between us, rather than, again, this quite fixed form of what the automaton, the robot in these spaces might be. Sue Gwen also challenged this idea of cultural expectations and norms, both about drawing practice and about technical forms, with her own very specific form of practice with it, and which also I think brought out some of the other parts of this, which was, this isn't a dry conversation. This is people who are doing this, and this is people having fun and butting up against these systems which we're building. Ones where we're, as she put it beautifully, actively shaping a cultural imagination. And that also, to tap back into Ellie as well, that sits in a very rich history of automation. Again, none of these things, although, you know, we might think about this in terms of thinking about automation and robotics, but none of these things are super new. They've been around for a long time in lots of forms. And like, is a kind of a standard thing that whenever we're trying to understand something complex or touchy or political about technology, any good historian will have like a really good story for you about it. And finally, to come to Erin, looking towards the future, the kind of fascinating work of the possible futures that we have, not a very specific one robot-driven future where perhaps there's an expectation about what roles we're going to have, the jobs that will exist, but there's kind of this broader open space that, again, as you described beautifully, is somewhere that's much more open to being shaped and discussed rather than something that's just like coming down the train lines at us. And I think also, again, what I loved about these talks was everyone here explored and challenged the assumptions baked into a lot of discussions and presentation around AI, automation, robotics, technical systems, but also said, well, this is what we can do about it. This goes beyond discourse. This also goes into making, to practice, to teaching, to forms of like active engagement with these systems as well. So that while we're taking us back to first principles, querying what automation, robotics might be, we're also kind of cracking that space open. We're not, unfortunately, given the times we find ourselves on, we're not in Ellie's kind of courtly pageant. We're not having water mostly spat over us by irate automatons. We're in a space that, as many of the panelists talked about, are rich with very emergent new technologies around machine learning, these sensor-rich environments, which transform the machines we work with and ourselves into part of a much wider network, a node of practice. So the final thing I guess I want to end on before we move to the Q&A is, I mentioned this idea of socio-technical imaginaries, this idea that there is often in the public imagination what automation is, what AI is, what a robot is. And I kind of want to emphasize, well, these imaginaries have power for a reason. They can be seductive, as Ali talked about. These can be things which can be impressive, amazing. They can discomfort us, they can terrify us, but they have affect. They do things to us. We buy into them. And I speak for myself here, but I know we've got, how many have we got? 146 of you out there in the audience, which is great. And I imagine that you're here for a reason as well. Like you're not here, or you're not at a presentation, at a panel that would be about another subject. You're here because you are excited and want to know about all these facets around automation, around computational systems. And we think they're really fascinating and they're great. But there's this big thing about reflecting on ourselves and the choices we're making in why we choose to engage with them, how we can choose to both think these things are really fascinating and reflect on the kind of the power dynamics that run through them. And I think to come back to, Erin in her talk talked about not being a futurist, but there is this form that we do through the forms of work that we do, both us on the panel, the hosts, and you as well in the audience. So I'm guessing there's a bunch of students out there who are moving into this world, through creative practice and research and teaching and learning. We are feeling our way towards these many possible futures here in which we can reflect on the systems and ask ourselves, what do we want to bring into being? What are the choices we're making here with these systems? So I'll wrap up there and I will now move on to a round of questions, one for each of the panelists, just like Christmas, and then we'll see what the Q&A has got to go. So let's think about order. I think Stefana, actually, I'd like to kick off with you. I'm really fascinated about what you talked about in a lot of your work about building your own tools. And I was wondering what challenges you'd met in doing that, kind of at what point you realized that the tools available to you just weren't going to work off the shelf. And how that works in teaching, how it works for students when they're, given this wide open space to play with, rather than something that's more constrained by the kind of the design environment of something more rigid.
Yeah, thanks. Thanks, George, also for wrapping things up, bringing it all together. And I want to take just 2 seconds to say how amazed I was by everybody else's presentation. But I'll jump into your question. Yeah, the challenges that I've encountered, I'd say pretty much everything you can imagine, from just not knowing where to start from, how to dive into these things that are every time completely new. It's not like you do the same thing twice, and particularly in research and in engaging with new technologies and different fields, it feels every single time like I'm a beginner, and I have to figure out where to start, where to even go towards. So takes a while to build up the confidence also that one is actually fine diving into these new concepts, methods, all of the above, so to say. I did start though, like I wouldn't say that I tried out all existing tools and at some point I figured that's not really enough. It kind of seemed self-understood very early on when working with these machines. There were also not many tools when I started working in computation and robotic fabrication. So I kind of just immediately dove into making my own tools and developing things. And teaching is indeed challenging. I will admit that it's not easy. A lot of students come with the expectations of quickly implementing some robotic process, and they hit this wall that, wait a second, why aren't you giving us a plugin where we can click a button and things just happen in front of us? And I put a lot of emphasis on not doing exactly that, but having them engage with the low level knowledge that's behind it, which is not easy. I do hope they take away out of that this is feasible, and it's, even though complicated, it's not something that we as designers or architects are just not prepared for, but it's something that we can engage with at every point, and that they learn that this opens up more possibilities than working with black box tools. Because I don't think any of the processes they did implement were, I don't think they would have imagined those processes if they hadn't engaged with the underlying difficulties, challenges, and so on.
Thank you so much. It's something I think a lot about with my teaching and work, and it's really nice to hear that, you know, a lot of the same issues come up or over, but also that particular thing of the idea of doing it through practice, of, you know, where a bounded space only gives you so much, you know, to play with, but when you crack that open, you're suddenly, like I said, dealing with much wider expectations, and that's so lovely. Let me see, Ellie, then coming on to you. Hi. Again, like history of technology, just brilliant. I was so delighted to hear your talk. What I was wondering when I was kind of looking through your notes earlier and looking and hearing your talk today was, you locate, particularly in this talk, you know, the historical figure of the automata put to use by power in different ways, whether through the court, whether it's like, you know, showmanship. And I was wondering, given that clearly to create an automata, you know, as we all know on this panel and in the audience, requires a lot of resources, you know, time, money, wood, metal, whatever. Are there examples that you can think of, or interesting stories where people maybe with less resources than those you've talked about were able to either push back, make something, create a counter narrative in some way? So I think, you know, we finished by thinking about the alternative pathways that we take, and that's something that certainly a lot of the panel are, you know, are doing and thinking about. But I'm curious about in history, is there something kind of fascinating that might come through there?
That's such a great question. Thank you. There are examples where individuals pushed back against automata. So for example, there are a couple of stories of versions of the learned man and his automaton child, in which the automaton is usually destroyed, but it's usually destroyed by people who are presented as being ignorant. They don't understand the true technology, and so they are afraid, and that they let their fear speak for them. But I think, you know, the things that I think about, or it's not so much ways of pushing back, but I like seeing these moments in the historical record where you can get a sense of the other people involved. So that this is really, these objects are appearing and they're being built within an entire ecology. So even though, for example, the Duke or the Count may have been the one who says, this is what I want, this is what I want it to do, this is what I want it to look like, we see in the historical record, you know, like the monkeys had to be sent to the refurbisher, the repelter, every year or two. And you just think, you know, that's that guy's job. he's thinking every year, like, oh, here he comes again. It's the monkeys. And so I think it's important to kind of remember that even though, so what I try to do as a historian is that even though those artisans perhaps don't speak to us as directly in some ways, they're there in the records. And so we have to just remember the ways in which they are contributing to the process or changing it in some way. But I unfortunately haven't come across many examples of the truly liberatory automata or servants that I might hope for, but I continue to hope that people like, Aaron and Suguen will, and Stefana will help get us there.
Thank you. And that brought up a bunch of things for me, I guess. Partly, this idea of kind of like the wider network of production that exists around technical systems. And I've been thinking a lot about, I guess, some of the current discourse on, if not Silicon Valley, but those technical systems that often focuses very heavily on those who have worked in upper tiers and then left and been critical. And there's an entire range of other people, who are involved historically in working in those processes, who may be more marginalized, have less power, but as you say, comparable to the Pelt manager, also have a valuable part to play in the network. And I would love to read whichever fiction writer picks up that guy's story and turns it into like the great historical science fiction. So yeah, audience, I'm looking at you for this. Otherwise, I will take it. Coming on then to Suguen, it's always so lovely to hear you talk about your practice and see it as well. And this time was absolutely no different, just an absolute delight. You kind of answered the question I was going to ask you at the end, but I'm going to ask it anyway, and maybe we can talk a little bit more about it. You talk about at the beginning of kind of like this particularly this past decade of doing this kind of work, that you were challenging your own and questioning through practice your own expectations of what your drawing practice was and the idea of computational systems and engagement. And at the end of your talk, you mentioned, at this point in time, how you're reframing and rethinking a lot of, what's happening now and what that means for how that gets embedded into your practice and wider life. And so that was basically the question of what are the challenges you're facing, you or the kind of the questions you're asking now, the kind of the comparable ones, or the kind of like the longer thread that starts at that early one 10 years ago of like, what's this mean for my drawing? How has that evolved and where are you now? And how do you feel about that?
That's a big question. And of course, it's like one that I've been thinking about a lot, given I've spent a lot of time in my studio recently, but and it's also with how the world has changed. I think, prior to this year, and, I was thinking a lot about automation, obviously, and how automation is not just a technical challenge, but it has a lot of social implications and a lot of emotional sort of responses that I feel like, I feel like it's part of my practice to address and reframe and rethink what that can mean, that dynamic between human and machine. And I think lately I've been thinking a little bit more about how we can use interactions in these processes in co-creation with machines and AI systems and all that. And, even VR technologies to really expand our internal model and what's sort of what we think of as sort of single authorship, or what we think of as, sort of what I was talking about a little bit with like the Copernican trauma of thinking we're single authors alone in the universe. Now with this sort of synthetic sensory apparatus, we're able to actually connect in new ways and see through, machine learning algorithms and also feedback. I specifically use recurrent neural nets for that reason, to sort of have that feedback, but also sort of just observing the mass amounts of information that we can have at our disposal. I mean, I think what that does to the human subject is really interesting, and I'm interested in ways of bringing that into my practice really explicitly, because I think it helps with my own anxiety about potential futures, but also helps us imagine new ones through this embodied making, which I narrativize, but I also design and sort of think about and write about. So hopefully that comes across in some of the work. I think I'm still working on how to do that. But for me, it lands a lot in what the painting artifact is and what that is as a mode of speculation and contemplation. I think that follows along, certain cultural practices and the larger narrative of art history. And I feel like a lot of times conversations about art and technology sort of ignore and dehistoricizes a lot of what came before, and what we're sort of really engaged with right now is how we can continue that conversation and not erase, like cultures and histories through thinking about futures with machines or AI or whatever. So that's what I've been thinking about a lot.
And thank you for sharing that. And I think, yeah, that point at the end actually beautifully articulated something I know that probably a lot of us have been thinking about, but have been rattling around in my head. Of, we see where particularly computational technologies, or a narrative around computational technologies can be very ahistorical, can be very kind of like constantly like, I don't know, a shiny wall just moving ever forward and there's nothing behind it. It's just like always there and always shiny. And particularly, in the art space, that's fascinating against, the history of art, which, as much as history of technology is so fascinating and so rich. But it's, yeah, I think that's a really useful articulation of how just by sellotaping on, or, bringing in that digital computational part, suddenly this rich, long practice just becomes this thing that exists now. And in a moment, it's going to exist there as well. That was really beautifully put. And I guess then on futures, I will come finally for these questions to Erin. So it was great to see the Autodesk work. I mean, like many of us here, I was part of the arts residency at Autodesk, and it's just lovely to see what's going on and where you're going with that. And I think what I found fascinating about your talk is like you were very, you said, I'm not a futurist. You presented like really rich and intriguing ideas, but in a very pragmatic way. It was like, the future is not this blinding thing that's going to terrify us. We're going to take a look at it. We're going to think about this, and it might not be what you think. So what I was interested from you, I think, which I mentioned earlier, is when you present these ideas, whether internally or externally, where you're saying it's not some kind of jetpacks on the moon kind of thing, it's actually something which is more complex, which might push back against the ideas you've got. How is that received? How has that been taken on by audiences? And I guess as a backup for that as well, of like, what has surprised you in your own work as you've been doing this very complicated, very fascinating research about, I guess, technological futurity?
Thanks, Georgina. I think that, so how is it received? And I did intentionally explain that I'm not a futurist. And that's primarily because I think that throws folks off when we say we're a futurist. It's as if I can, gaze into a crystal ball. And it also implies that there is one future, that there is some sort of, linearity, and, we just haven't extrapolated out as far as we can see, but it is a continuum. And that's, I think, what, in terms of how is it received, it's received well, certainly within our organization, because we have come to a point where we admit to ourselves that there are many parallel possible futures, certainly depending on what lens we're looking through. So is it a social lens? Is it a technical lens? Is it an economic lens? But also because there are, it is not a dichotomy. It is not either dystopic or utopian. There are desirable futures and there are undesirable futures, and it behooves us, all of us, to analyze all of the possible futures, as many as we can imagine. So it is, limited to our imagination, and then identify what it is that we need to do to navigate toward the desirable futures. Desirable for the environment, desirable for society, desirable for the economy, and so forth. So what you also asked, what surprises me? What has surprised me is how profoundly interdisciplinary the act of looking into the future around a technology, not just robotics, but certainly robotics. I think, you know, Stefana, she had to pick up, you know, technology from scratch, as you rightly pointed out. And this is what everyone who is pushing the boundaries of robotics is doing. You know, they're soldering and wiring new systems, you know, from the ground up. And at the same time, they need to understand, you know, the implications if it's applied in architecture, the implications and the interplay between design and fabrication, and how to, you know, how to craft not just a, you know, a pragmatic design, but an aesthetically pleasing design. So this, you know, interdisciplinary nature of robotics is what surprised me most when I first moved into this team.
Thank you. I think, you know, we are definitely all on team interdisciplinarity here. You know, we may not be able to necessarily pronounce it, but we believe in it as well. And I again, as someone who's worked, you know, has looked at imaginaries and socio-technical futures, the talking about the plurality of futures feels so important. I think to come back to what we were talking about with Sugwen, there can sometimes feel like there's one steering force and you're going to strap yourself to that engine, you're going to get that future somehow. And, you know, we're talking here about it being a broader, messier array where there's active choices. It's not about being kind of like sucked into the vortex of, you know, 30-year time horizon. It's about the choices that get made along the way and who gets to make them. So I think we've got a bunch of questions coming in. We also don't have much time. I'm terribly sorry about that, but I hope what we've talked about here has been good. So I'm going to try and very quickly go through some of the questions we've got here. We've got 10, so that's about a minute a question. So very quickly, Shelby Doyle asks, as architectural robots have evolved into many species of design collaborators rather than human proxies or perfect slaves, does this shift in thinking change us? Does rejecting frameworks of enslaving technology shift our thinking about ourselves as designers, how we locate and value human labor, or how we engage with computational labor practices? Great question. Does anyone want to jump on that one? The question being, does this change? Does this as we've shifted our understanding of robotics, does that shift how we conceive our own practice?
I'll jump in, primarily because you know, I am not an architect, so I resisted answering, but I am a computer scientist, and what we look to do within our technology development is not automate the process of design and make, but produce tools that allow this interplay between the technology and the creator. And I think, you know, Sugwen described this nicely as interdependence. And I think that is really the design characteristic we want to strive for in the future, and the relationship between our robots and our designers. And it's one of interdependence, it's one of collaboration, not one of dependence and automation.
I think I can also piggyback on that a little bit. And, you know, in my practice anyway, and part of what, you know, even though like terms like enslaving technology is like very loaded, I do think about what human skills become atrophied through a purely executional, like linear approach to engaging with robots. And I think that's why by framing this work as a collaboration, it becomes one where not only are both processes evolving sort of in real time, but it doesn't actually, it's sort of a self-limiting engagement that deepens the engagement with both human and machine collaborators. So I think that's where I'd like to be headed, one where it's not about control, but or execution, but about catalyzing new types of knowledge. So that would be my preferred future.
Just to add on to that, but I think this understanding of the machine as a collaborator in a way, rather than an executor, also, it can also be seen as a parallel to how I hope and I think that the architectural profession is evolving, and the process of designing, that we just don't see the architect as the one lonely creative genius who generates something which is then executed, right, by people. But in a way, our relationship to the labor of making things and executing things also shapes the way we design things.
Thank you. I think at that point we're kind of at time. Maria, if you want to kind of call us back in like little ships. We have got a lot of lovely questions, but we will be able to look at them later and maybe think about them and get back to you in different ways as well.
We are unfortunately kind of at time. Honestly, I really wish that I could just not have to cut you off and we could continue chatting for forever and ever and ever. But I do have to, in the interest of the rest of the conference, I would like to make sure that all of you are aware that our upcoming panel that is titled Architects PPE Response will be starting at 6:00 p.m. Eastern Time. And I heavily encourage you to all log in and listen to the wonderful, wonderful panel. I would also like to mention that both George and Sugwen have projects in our curated project session on the ACADIA Distributed Proximities website. So go there, search their names and find the projects and learn more about their work. Stefana's students will be presenting tomorrow. We'll be presenting the paper on the latest Glassfold project, and I also encourage you all to be there. And with this, I think we're going to have to wrap up this session. Thank you so much. It's been such a pleasure and such an honor to have all of you in this room. I personally have been smiling throughout the whole event, and my face is now tired. Thank you so, so, so much.
Thank you.
Thank you.
Thank you.
Thank you so much.